Hello, welcome back to Every Problem. This is Stewart Calculus, section 1.4, problem number 5. Problem number 5 has many parts to it. Part A says write an equation that defines the exponential function with base b greater than 0. So quickly, we'll write the exponential function as y equals f of x equals b to the x. You could have some constant multiple next to b as well. It could be something, depends on what variable you use, but really it could just be c times b to the x, where c is some constant. But anyways, the general idea is just b to the x. So what this means is, let's see. Write an equation base b greater than 0. Let's choose 2. That's a pretty standard one. So we'll have f of x equals 2 to the x. And we have to make sure we don't confuse the exponential function with a power function. Power function being x squared. That's they're two different things. X squared, you would have like maybe 1 squared or 2 squared, 3 squared, 4 squared, right? With the exponential function, it's 2 to the first power, 2 to the second power, 2 to the third power. So it's a different type of function. Similar in style, that the growth is exponential, but yeah. Anyways, okay. So that's part A. For part B. What is the domain of this function? Well, you could plug in any number, really. So we'll just go ahead and write from negative infinity to positive infinity, again with open parentheses here, right? Because we can't close off infinity, so it's an open interval. If b is not equal to 1, then what is the range? Okay. The range is the output, so what are all the different outputs with this? Well, if we put in a really large negative number, right? Like, suppose we put in 2 to the negative 100. That would be the 100th root of 2. Just looking for a calculator really quick, but I don't see it. But regardless, the 100th root of 2 is an extremely small number, so that's just going to get closer and closer and closer to sorry, that's not that would be 2 to the 1 over 100 would be the 100th root of 2. I knew something was looking wrong there. 2 to the negative 100 is equal to 1 over 2 to the 100. So that's an extremely small number, right? Anyways, you can see that number is approaching 0. And, well, what if we plugged in 100? It would be a very large number. So the range is going to be from 0 to infinity. It never actually reaches 0, though. The line, the line y equals 0 is going to be an asymptote, so it'll never reach 0, but it'll get very, very close to 0. And then D, it says, sketch the general shape of the exponential function for the following cases. We've got base b greater than 1, equal to 1, and in between 0 and 1. So let's do that. We'll have b is greater than 1. We have our asymptotes here. It's going to be something like this. Okay, and the line here, it will cross the point 0, 1, because if we have b to the x, where x equals 0, then that'll give us b to the 0, which anything to the 0 power we have equal to 1. Okay? Now, if b equals 1 exactly, well, what happens if you have 1 to the x? That's just 1 and 1 again and 1 again, right? So if you have 1 to the x, that's looks like no matter what you have, you're just going to have this line here at 1. You'll get 1 every time. Even if it's a negative number, like 1 to the negative 2, you just have 1 over 1 squared. So, congratulations, it's another 1. So every time it's going to be 1. Now, what about between 0 and 1? That's interesting. So between 0 and 1, suppose b to the, let's say, oh, not b, we'll say, suppose you had like 1/2 x. That's going to give us actually a sort of a reflection of b to the x. So we still have our asymptotes as usual, but this is going to be more so like this. It'll still cross the point 0, 1, but it's going to go in the reverse direction. And that's because if we try to figure out why that happens, if we have 1/2 to the 4th power, that's going, suppose we have 4 over here, it's going to be 1/2 times 1/2 times 1/2 times 1/2. So you end up getting what, 1/4, 1/16. So it gets small very quickly in the positive direction. Suppose we had 1/2 to the negative 4th. Well, you would take 1/2 and you would flip it, because you would have 1 over 1/2 to the 4th, and when you get 1 over 1 over 16, that's the same as saying 1 times 16 over 1, which is equal to 16. So you see, you'll have you'll have positive 1/16 here, but at -4, you'll have something like 16 over here. So that's why whenever you have a fraction to the x power, the line is reflected along the y-axis. Let's see, was there any... I don't think there were any other problems here. Nope. So that's going to be everything for problem number 5.